In this second tutorial on finding unknown side lengths using SOH CAH TOA, we carry on working through some examples in which we need to find the unknown side length x. And as we're about to see, the algebra in these examples is slightly more complicated. Nothing we can't handle though. So let's get started. Looking at this first triangle we have here, we need to find the unknown side length x, which is here. As always, the first thing we need to do when faced with this type of question is pinpoint the interior angle that we're given. And in this case, that's this 32-degree angle here. Now that that's done, our next step is to summarize all the information that we're given relative to this 32-degree angle. We can see that we're given the side length 8, which is opposite to the angle, so I mark that with a capital O for opposite, and that the side length that we're looking for, x, is the hypotenuse of this right-angled triangle, so I mark that with a capital H. Now that we've summarized the information, our next step is to look through the words SOH, CAH, and TOA for the only one of those three words containing the letters O and H. And it doesn't take us long to see that the only one with O and H is SOH, which, remember, tells us that the sine of an angle equals to its opposite side length divided by the hypotenuse. So we can go ahead and write sine of 32 equals to the opposite O divided by the hypotenuse h. Now replacing O by 8 and h by x, this becomes sine of 32 equals to 8 over x. And now we can see why the algebra in these examples is slightly more complicated. Here we have x, which is written on a denominator, and we have to get it away from there. And the trick for doing that is to use inverse operations. Here's how that works. The x that we have on the right-hand side here is dividing the 8 which is written on the numerator. So to get rid of this x here, we're going to multiply the right-hand side by x. In other words, I write times x. But just as for any equation, whatever I do on one side of the equation, I have to do on the other. So I'm going to have to multiply the left-hand side by x as well. And that leaves us with x times sine of 32 equals to 8, which is being divided by x and multiplied by x. Since those two operations cancel each other out, we're just left with 8. And here we can see that x is no longer written on a denominator. Instead, it's multiplying the sine of 32 on the left-hand side here. And we carry on. The left-hand side here can now be thought of as x being multiplied by sine of 32. So to get rid of that sine of 32, we divide the left-hand side by sine of 32. And as always, whatever we do on one side of the equation, we have to do on the other. So I'm going to divide 8 by sine of 32 as well. And that leads us to x times sine of 32 divided by sine of 32. Those two operations cancel each other out to leave us with x. And that equals to 8 divided by sine of 32, which we write 8 over sine of 32. And at this stage, we're done with the algebra. Indeed, we have an expression for x. All we have to do now is use our calculator to evaluate 8 divided by sine of 32. And in doing so and rounding to 2 decimal places, we find that x is equal to 15.10. And that's the final answer. Let's look at the next example. Again, we have to find the unknown side length marked x. Our starting point never changes. We pinpoint the interior angle that we're given, and that's that 50-degree angle there. We now summarize the information we're given relative to this 50-degree angle. Looking at this triangle, we can see that we're given this side length 7, which is opposite the 50-degree angle, so I mark it with a capital O, and that the side length that we're looking for, the x we have here, is adjacent to the 50-degree angle, so I mark it with a capital A. Now that that's done, I look through SOH, CAH, and TOA for the only one of those three words containing both the letters O and A. And it doesn't take us long to see that the only one with both O and A is TOA, which tells us that the tangent of an angle equals to its opposite side length divided by its adjacent side length. So we can go ahead and write that tan of 50 equals to its opposite side length O divided by its adjacent side length A. Now replacing O by 7 and A by x leads to tan of 50 equals to 7 over x. And once more, we can see that the unknown x is on the right-hand side's denominator. So to move this x away from there, we're going to multiply both sides of the equation by x. In other words, we multiply 7 over x by x and tan of 50 by x, which leaves us with x times tan of 50 equals to 7 divided by x times x. Since those two operations cancel each other out, that's just 7. Now on the left-hand side, we can see that x is being multiplied by tan of 50. So to get rid of that tan of 50, we're going to divide by tan of 50. So I go ahead and write divided by tan of 50. And as always, whatever I do on one side of the equation, I must do on the other side as well. So I divide 7 by tan of 50 as well. That leaves us with x times tan of 50 divided by tan of 50. Well, that's just x, which equals to 7 divided by tan of 50, which we write 7 over tan of 50. And at this stage, we have an expression for x. All we have to do now is use our calculators to evaluate 7 divided by tan of 50. And in doing so and rounding to 2 decimal places, we find that x equals to 5.87. And that's the final answer. Let's quickly work through the third and final example. Again, we have to find the unknown side length marked x. Our starting point is still the same. We start by finding the interior angle that's given to us. In this case, that's a 58-degree angle we see here. Now we summarize the information we're given relative to this interior angle. Well, we can see that we're given the side length 6, which relative to that 58-degree angle is the adjacent side length, so I mark it with a capital A. Furthermore, we can see that the unknown side length x is the hypotenuse of this right-angled triangle, so I mark it with a capital H. Now that that's done, I look through SOH CAH TOA for the only one of those 3 words with the letters A and H inside of it. And it doesn't take us long to see that that's CAH. And CAH, remember, tells us that the cosine of an angle equals to its adjacent side length divided by the hypotenuse. So for this 58-degree angle, we can go ahead and write that cosine of 58 equals to its adjacent side length A divided by the hypotenuse H. Replacing A by 6 and H by X, this becomes cosine of 58 equals to 6 over X. Once more, we can see that the unknown X is on the right-hand side's denominator. To get it away from there, we're going to multiply the right-hand side by X. So I write times X here. And as always, whatever I do on one side of the equation, I have to do to the other side of the equation. So I multiply the left-hand side by X as well. And that leaves us with X times cosine of 58 equals to 6 divided by X times X, which is just 6. Now we can see that X is being multiplied by cosine of 58, so to get rid of this cosine of 58, we're going to divide the left-hand side by cosine of 58. But as always, since I'm doing that on one side of the equation, I have to do it on the other, so I divide the 6 by cosine of 58 as well. So that becomes X times cosine of 58 divided by cosine of 58. Those two operations cancel each other out to leave us with X. And on the right-hand side, we have 6 divided by cosine of 58, which we write 6 over cosine of 58. And at this stage, we've gone as far as we possibly could without a calculator. Indeed, we have an expression for x. All we have to do now is use our calculators to evaluate 6 divided by cosine of 58. And in doing so and rounding to 2 decimal places, we find that x is equal to 11.32. And that's the final answer. And there we have it. Now that we've seen this tutorial as well as our first tutorial, we can comfortably say that we know how to find an unknown side length in a right angle triangle using SOH CAH TOA. And that's it for this tutorial.